Okay, hello everyone, welcome to our new video. In this video I will show how to download stock prices in R using the tidyquant package. So if you don't have it, you can install this package using the install packages command in R as we have done just like the other packages. It's no different. Once you install this package, you can include that, and basically we can access the functions in this package. And one of the functions is this get symbols function. And you can see there is the description as well. And we need to enter the Yahoo Finance ticker IDs. If you go to the website finance.yahoo.com, finance.yahoo.com, you can actually check the tickers for different stocks from different markets. And I will be using a specific stock. This is from our Turkish stock market in the Istanbul Stock Exchange. Sabancı Holding .is, that's the ticker ID for this. And suppose I want to start the date from 2017, January 1st, and all the way to the current system date. So actually I can run this and we can check this TT1, that's the current date in our system, okay, for giving the date for today. So you can set these beginning and end points for your time series data, and I'm just turning the warnings off. So these can also be included, and then we can run and we get the data. I mean, as you see, it appears here. We have these data set now downloaded already, and let me comment this one. And then we can check our data set, for example, the tail of the data set, or you can check the head of the data set. It's up to you, of course. And you can check, this is how our data set looks like from the beginning of 2017. The first observation starts from January 2nd, okay? And we have the open, high, low, close, and volume and adjusted close prices for whichever stock you enter. I mean, you can change this to, for example, let's say we have maybe IBM stock. I don't know, you can try different stocks. Now we have the IBM data. And again, you can easily check the data set. Now we have IBM. And this is the top portion of our data set, including, again, open, high, low, close, volume, and adjusted close prices altogether. Or similarly, you can check the tail again for this IBM stock. Okay, so and then as usual, if you want to, for example, select one column from this data set, you can use the $ as usual. Let's say I want to assign this close prices as my y, that's the dependent variable. And then, for example, suppose you want to draw a trend line for this stock price data set. We can do that. First, I am creating this sequence of values to capture the time trend from 1 to the length of this data. So we have this x1 that's created here. As you see, we just increment one by one, going over different days of the data set. We just want to add a time trend to our data set. So you can now put these things in a regression. You can use the LM linear model function here. As you see, we need to have a formula. We need to input some data, of course. So our formula is we are explaining the close prices. For example, well, you can put y here, and you are using x1, which is your time trend. Okay, so if you enter the data, we have the x1 and y, and then basically this will produce us the fit, and you can check the fitted coefficients are given here. The intercept and the coefficient for the time trend are given. You can present summary of your regression results as usual, no different from the previous regression example. As you see, we have also the t-value and the p-value. P-values are again very small, indicating that the coefficient for the time trend is really significant. And similarly for the intercept, it is also significant. There is also another nice function in this package. You can use and create some charts. Again, you can access to the variables in your fitted regression. So these are the available variables. So we can access to the residuals, the degrees of freedom, coefficients, etc., or the fitted values. These are accessible as usual using the dollar sign. And again, we can calculate some basic statistics, descriptive statistics of these residuals. We can calculate the standard deviation, or we can basically assign the fitted values from the trend line, and we can assign that to y hat. And then finally we can construct a chart. And once we create our chart, we can see that this is our stock price given with this ticker ID. And as you see, there is the trend line, the fitted trend line is also given. Okay, and we can see a nice evolution of the stock prices over this time period until basically the last date that our data is available, that is downloaded already here. You can try this with many different other stocks, and we can actually also fit other types of models, not necessarily just the trend line, but we can try other combinations. And also, if you want to calculate the, let's say, log returns from the stock prices that we download, again, we can do that easily using the natural logarithm. And as you see, this is the price vector. I just assign this dependent variable y now as a numeric vector to this price. So you can run this first, and we can check the content of price. As you see now, all these are numeric values assigned to my price vector. Now finally we can calculate the log return vector. So we create this variable log return, and we can just take the difference of log prices, but we just need to be careful with the index, because we are using the index, let's say t plus 1, and we are dividing by time t. So there is a one step difference between the elements of the left side and the elements on the right side, because actually we are representing the next time step in this vector from 2 to the end, and here we have the time t corresponding to the values from 1 to the maximum minus 1. So if we take the natural logs and take the difference, this will give us the definition of the log returns at a daily scale here, because our data set is collected daily. So we are calculating the daily log returns for this example. And you can use this formula, and for example, you can create a histogram of the log returns. Again, this is quite useful when we try to, let's say, model the risk of this stock, carrying this stock in our portfolio. histogram can be used to understand the tail behavior, for example. So you can run this, and this produces us the given histogram here for the daily log returns that we calculated for this given stock price. And then you can do other things, other operations. One more thing I would like to mention before we close this video. We can calculate again the mean standard deviation, and then I can actually fit a normal distribution for this log returns data. And for this purpose, I'm preparing my grid to evaluate the normal density function. And the grid points are coming from the sequence that covers from the minimum of the log returns all the way to the maximum of the log returns. And the length of this sequence will be 300. So we prepare this x values just as a grid line. And using these x values, we evaluate our normal density function at these points with the given mean and sigma that's calculated from our log returns data. And once you have that, you can create also a plot like this one. And this shows us the fitted normal distribution for this data set. Okay. So this completes the video, and I hope this is helpful for you. And if you need to download the stock prices and then work with the log returns for a specific stock, you can refer to these examples. Thank you for watching.